Okay, so part E. The national grid supplied a house with 18 million joules of energy in 1 hour. What was the average current supplied to the house during that hour? Write down any equations that you use. Okay, so we need to find, so what was the average current? Write down any equations that you use. Now, in June 2023, you'll be given the equations you need, so it may well say use your equation sheets. It's worth 5 marks, this one. So even if you've got to find the equations, it's 5 marks. This is going to be a tricky question, we know that straight away without even really thinking about the question, just looking at the number of marks. So the national grid supplied a house with 18 million joules of energy in 1 hour. Okay, so the average current, well, whenever we're looking at current, we're always thinking about current is per second. Remember the amount of charge flowing in 1 second. So what we're going to look at, I've got things I need to, in terms of symbols I'm looking for. I know, what do I know? I know that the potential difference, because it's mains electricity, is 230 volts. I've got current, I'm not sure what that is. I've got energy, which is equal to 18 million joules, and I've got time, which is equal to 1 hour. Okay, so I've got these values here, and sometimes it helps just to write down the symbols that go with them. If I've got time in an hour, we rarely use hours, so actually I'm going to convert that straight away into seconds. So 1 hour is 60 minutes. 60 minutes is 60 times 60 is 3. I always get mixed up. It's 3,600 or 3. 60 times 60 is equal to 3,600 seconds. I've got energy and time. I'm probably going to have to use therefore power, and if I find power, then there's a formula relating power and current and voltage as well. So I know that power, P, equals V times I. But I'd also need to calculate the power. So I also know that power equals energy divided by time. Okay, now I can find power out straight away because I've got energy and I've got the time. So let's work that out. So I've got my equations, I've got my values, I've converted my values here. So I'm going to put those into equations over here now. So I've got energy, power, I don't know what that is, power equals 18, 1, 2, 3, it was 18 million, wasn't it? Yeah. 1, 2, 3, divided by time in seconds, which is 3,600, gives me a total power of 5,000 watts. So I know every second there's 5,000 joules transferred. I can then use this, I've now got power, I can use that over here because I know potential difference as well. So let me substitute this back into this equation. So I've got 5,000 is equal to 230. The tricky bit here is you've got to remember this is UK mains electricity. So as soon as you get a question with UK mains electricity, it means you already know the potential difference is 230 volts because it's always 230 volts in UK mains electricity. So I'm going to rearrange, I've entered my values and now I'm going to rearrange it and solve it. So I is equal to 5,000 divided by 230 equals, so 5,000 divided by 5,000 divided by 230 is equal to 21.739. Okay, now I'm going to, it doesn't tell me to round that, but I am going to round it. And if I look here, in terms of significant figures of the data I've been given, the most significant figures anything's rounded to, anything's given to me is this 18,000 here, which is given to 2 significant figures. So I'm going to keep this to 2 SF as well. So it's 22 amps to two significant figures. Now it may well be that I'll go back and check here. First of all, does it say how many significant figures I should give the answer to? The fact it's given me a really long, complicated answer means I might want to check my numbers, just to make sure I've done my maths correctly. Yeah, I think in this case, looking at the mark scheme, if I'd left it as 21.739 amps, that still would have been fine. Okay, so don't panic if you rounded it to 21.7 or 21.74, that would have been fine. Okay, hope that helps.